So we're going to dive right in. We're looking at a technical exchange that it started incredibly small and ended up, well, I think it ended up completely redefining how we should think about modular computing.
Yeah, it's not just about a Raspberry Pi. This is really a deep dive into that tension between, just retrofitting old tech to be sustainable versus demanding real system-level innovation.
And what's so wild is that the initial problems, the technical walls they hit, they weren't actually obstacles.
No, not at all. They acted like a pressure cooker. They forced the person asking the question to get uh, much clearer about what they actually wanted. And that clarity led to a huge conceptual breakthrough.
Exactly. So our mission today is to just unpack that pivot. How a simple question about using an old laptop for parts basically evolved into this whole design philosophy for a standardized laptop shell.
And the stakes, I mean, you mentioned it, but they're not just technical. We're talking about e-waste,
Yeah.
but turning these obsolete laptops into something functional, something portable.
Right. So let's set the scene. The initial question was, I mean, it sounds so simple. It was, is it possible to use an old laptop as the drive for a Raspberry Pi?
Okay, and for this conversation, I'm going to take the role of the skeptic, the voice of existing solutions. My position is that everything this user wanted in a screen, a keyboard, portability, it's already solved. It's solved by software or by products that are already on the market.
Yeah.
I need to be convinced there's real innovation here.
And I'll be the innovator's advocate. I'm going to argue that the final concept, this standardized laptop shell, is a genuine innovation because it's all about hardware modularity and retrofit potential. And it solves problems that something like VNC or SSH just, well, they can't touch.
All right, let's start at the beginning then.
Mm.
The 1.31 p.m. timestamp in our source material. This is where we hit that fundamental misconception.
Yeah.
The user's idea, using the laptop as storage, it was met with a really sharp response. It was called technically possible but monumentally stupid.
Yeah.
You have to dig into why that was so brutally accurate.
I think we can all picture what the user was thinking, right? You take the Raspberry Pi Imager software, the thing you use to write the OS to an SD card, and you just point it at the laptop's hard drive.
And right there, that's the first huge technical wall.
Mm.
The immediate danger of just catastrophic data loss.
Mm-hmm.
If you could somehow get past the laptop's own operating system and its security to write that Pi OS image directly to the main drive, you would wipe everything.
Everything. Your Windows install, your Mac OS, all your photos, your documents, gone.
You turn a $500 piece of hardware into a complete brick, a blank slate.
Which is bad enough, but here's the kicker. The part people miss. Even after you've destroyed all your data, the Pi still couldn't boot from it.
Exactly. That's the critical point. A computer, any computer, needs its boot storage physically connected. For the Pi, that means the SD card in its slot or USB drive plugged into one of its ports. The Pi has no mechanism, no way to sort of reach out over a cable and say, hey, I'm going to pull my operating system from the storage inside that other computer. The architecture just flat out doesn't support it.
So, okay, that first idea, complete non-starter. But the user clarifies. They say, look, I don't care about erasing the drive. They want to connect the laptop and the Pi with a USB cable and just use the laptop like a weird, clunky external drive enclosure.
And this leads to an even more fundamental problem. This one is electrical. It's architectural. This is the infamous USB host versus device problem.
Okay, let's really dig into this boss problem because understanding this is essential to see why they had to pivot so dramatically later.
So think about any normal USB connection.
Yeah.
You have the host, your computer, it's the controller, it's the boss.
It's in charge.
It's in charge, exactly. And then you plug in a device, a flash drive, a mouse, a printer. That's the peripheral, the worker. The host initiates everything. It provides the power. It manages all the data.
The problem is a laptop is a host, and a Raspberry Pi is also a host.
They're both bosses. So when you connect two hosts together, they both expect the other end to be a subservient device.
And since neither one is, they just sort of stare at each other.
Nothing happens. The connection just fails. The whole USB architecture is designed by default to prevent that kind of communication.
So to make this work, the laptop would have to somehow change its fundamental role. It would have to stop being a boss.
Yes, it would need to go into a special state. It's called USB device mode or gadget mode. And the thing is, the vast overwhelming majority of consumer laptops are simply not built to do this.
Their ports are just hardwired for one job.
One job only. Host functionality. You might find that kind of feature on, industrial computers or really specialized embedded systems, but on a 10-year-old Dell, no way.
And let's say, just for the sake of argument, we can magically flip that switch. Then you run smack into the efficiency argument.
Oh, yeah. The laptop would have to be powered on, running its own OS, running special software, just to pretend to be a hard drive for the Pi.
What is?
The definition of absurdly inefficient. Think about it. You're running the laptop CPU, its screen, its fans, its memory. All of that is burning, what, 30, 40, 50 watts of power.
Just to do the job of a simple $10 USB to SATA adapter.
Exactly. An adapter that you can just plug the bare drive into, connect it to the Pi,
Yep.
and it works perfectly while using maybe a fraction of a single watt. It's a non-starter.
Okay, I totally concede the technical wall here. Using the internal drive is an absolute dead end. The USB host constraint is a reality. But that brilliant technical teardown is precisely what forced the creative pivot. And the user points out that the response kind of missed the forest for the trees.
Right, you're talking about the 1.35 p.m. timestamp when the user pushes back on the tone. They say, you're doing a lot of condescending remarks over a curious question.
Yes, and that's such a crucial moment, not just in this conversation, but for innovation culture in general.
How so?
Because in technical fields, we sometimes get so laser-focused on why something can't work based on the current rules that we completely shut down the underlying goal. The user wasn't really asking about technical feasibility. They were asking for a solution to a problem they had.
And they clarified that problem. The drive was just the wrong path to the right destination.
Exactly. They didn't really care about the storage. They wanted the interface, the built-in mouse, the keyboard, the monitor, the battery. They wanted to use the Pi as the computer and the old laptop as the pre-built hardware shell to run it.
They were trying to build a portable, integrated Pi workstation from parts they already had.
Yes.
And as soon as you clarify that goal, using the laptop as an integrated interface, the technical solution becomes obvious. You shift to established methods. You use the laptop as a thin client.
Okay, so let's define that solution, because this is the baseline. This is what the standardized shell idea has to be better than.
The standard off-the-shelf solution here is network protocols. Things like VNC, virtual network computing, or SSH, which is secure shell. So the Pi boots up normally from its own SD card. Both the laptop and the Pi get on the same Wi-Fi network. And then the laptop just runs a VNC viewer, basically remote desktop software, to see the Pi screen.
So the Pi is doing all the work. It's running the OS, storing the files, doing the computing. The laptop is basically just a very smart, very expensive external monitor and keyboard.
That's a perfect way to put it. It's a passive terminal. It's just rendering the video feed from the Pi and sending the keyboard and mouth clicks back over the network. It's a proven, robust, software-only solution.
Now, here's where I, as the innovator's advocate, have to push back hard on that initial dismissiveness. At 1:40 p.m., the user points out that the whole objection about power consumption, calling the laptop absurdly inefficient, was totally unnecessary.
They did. They pointed out that any PC setup needs power. You have a desktop PC, you have a monitor. Both need to be plugged in.
Right. A laptop running in VNC mode is no different. It just needs to be powered on. Conceptually, it's the same as powering a Pi and a separate monitor. So once you reframe the goal to using the laptop as an integrated terminal, that whole efficiency argument it kind of falls apart. Because the goal isn't a drive enclosure anymore, it's portability and integration. The concept is actually pretty clean. You get a screen, keyboard, mouse, and a battery all in one package for your Pi. That is legitimate reuse.
I'll grant you it's legitimate reuse, but it's still, it's a workaround. It's a bit clunky. You still have two full operating systems booting up and running at the same time. You're managing two different power sources, and you're relying on a network connection, even a local one, for it to work. It's not true hardware integration.
And that right there, that brings us to the conceptual leap. This is the most important part of the whole exchange. At 1:43 p.m., the user moves past just retrofitting their old laptop. They start demanding a standardized product.
This is the pivot point. They suggest the Pi Foundation should actually work with manufacturers to create laptop-like hardware that's specifically optimized for a Pi motherboard.
Yeah, they're basically going from a personal DIY project to proposing a whole new market category. The limitations of the VNC workaround, the network lag, the two operating systems, it forced them to ask a bigger question. Why can't this connection be direct and standardized?
They're asking for a system where the Pi just slots in. Direct connections for power, for video, for the keyboard, without all the software and network overhead.
Yes.
And this is where I, as the skeptic, have to bring us back to market reality.
Yeah.
This idea, it already exists.
Does it, though?
It does. We have the Crow Pi, an educational laptop built around the Pi. We have the Pi Top, which is literally a modular laptop shell made for a Pi. We even have smaller things like the Clockwork Pi DevTerm. The market is already serving this need.
So you're saying it's redundant, the problem is already solved.
I'm saying two things. First, the market proves the demand is real. And second, the Raspberry Pi Foundation's whole mission is the bare board. Cheap, modular, educational. If you start bundling it into a pricey laptop chassis, you lose that flexibility, you jack up the price, and you maybe even undermine the core mission. Third parties have already filled that niche.
Now, see, you're missing the key distinction. You are lumping this standardized retrofit shell concept in with existing proprietary systems. And that is where the real innovation is. That's the core differentiator.
Okay, convince me. What is the precise difference between an existing Pi top and this proposed standardized shell?
The existing products, like the Pi top, they're new products. You often buy them as a kit. The internal connections, the way the Pi slots in, it can be proprietary, maybe specific to one version of the Pi. The innovation here is standardization and retrofit potential.
Standardization how?
The vision is that a manufacturer builds the chassis, the shell, with a standardized slot. A slot designed for the Pi's form factor that connects through a common interface, like the GPIO pins. And the crucial part is, the user provides their own compute board.
Ah, I see. So it turns the laptop shell into a true platform-agnostic dock.
Exactly. It maximizes the life of every component. The chassis has the durable parts, the screen, the keyboard, the battery. The Pi is the disposable, upgradable brain.
So if your Pi 4 gets old, you just pop it out and slide in a new Pi 5.
Yes. Or if your screen dies, you take your Pi 5 and you put it in another shell or a desktop dock. This interchangeability fights planned obsolescence head-on. It's a dock, not a single proprietary machine.
Okay, I will concede that point. The focus on the complete separation of the chassis and the compute module is a genuinely different approach. It maximizes the reusability of the Pi itself. That's a strong angle.
And that leads us straight into the bigger philosophical argument at 1.46 p.m., the e-waste argument.
Right. The user correctly points out that when we just dismiss these ideas, we're ignoring the reality that old laptops running outdated, insecure operating systems they end up in a landfill or they collect dust in a closet.
And the e-waste reduction here is so compelling. It doesn't matter if you do the final shell idea or just the simple VNC workaround. Using that old laptop as a terminal costs basically nothing to implement. It gives a legitimate second life to hardware that was otherwise obsolete.
It's immediate, practical resource management. That laptop that was headed for the recycling bin is suddenly a functional, secure terminal for a modern computer.
This whole thing shifts the conversation from just a technical puzzle to, like, a social responsibility. The user is trying to maximize what they already have instead of just buying something new.
Yeah, and the fact that products like the Pi top exist actually strengthens their philosophical point, even if it might weaken their business case. It proves that the desire for an integrated Pi experience is real and valid.
Totally. Which leads to the final point here, at 1.48 p.m., about educational value. The original critique was that the Pi Foundation is all about cheap, modular, educational bare boards. But the user just flips that argument completely on its head.
They did. They argued that trying to figure this out, even just getting the VNC workaround going, is a better educational experience than just following instructions for a kit.
Why? Because it teaches systems thinking. It teaches you how to work with constraints and be flexible and creative. You're recycling hardware, building a makeshift PC. That's a real lesson.
It's the power of constraint.
Mm-hmm.
The initial technical dead end, the USB host problem, it forced them to think laterally.
Yeah.
They had to learn about client-server architecture, about networking, about finding a software solution to a hardware problem.
The source material agrees. It says that teaching people to do this hits multiple educational goals at once. It's not just about code. It's about practical e-waste reduction. It's about understanding system architecture. It's about working within hardware constraints.
It really reframes the whole purpose of the Pi. It's not just the world's cheapest computer. It's a catalyst for being resourceful.
Yes. The mission becomes, use this cheap little compute module to make the other, more expensive hardware you already own useful again. The technical wall they hit wasn't a failure. It was the lesson.
So we've established the idea is sound, ecologically, educationally. Whether you do it with the VNC workaround that exists now or this proposed standardized shell concept. The debate successfully went from, can I use the drive, to how do we design a new sustainable ecosystem?
Exactly. But the conversation isn't over. It takes a really sharp economic and philosophical turn right after this. We've proven the idea is valid, and the standardized shell is a cool concept.
Right. We need to talk about what happens at the 1.52 timestamp. That's where this goes from interesting hardware concept to actual innovation philosophy, specifically debating economic feasibility, intellectual property, and scaling this concept globally. We'll pick that up in Part 1B.